Okay, and we will start. Okay, and then we will start with our today's topic. Okay, so let's begin what we have studied in our previous chapters, what we have actually discovered in our previous classes, I would say. We have been going through the chapter that is electrochemistry, chapter number 3, that is totally dependent how an electrical energy is converted to make a chemical energy, or I can say chemical energy is converted to make electrical energy. Okay, this topic electrochemistry is very important, very crucial, and the best point is we have divided this in 3 different portions. Okay, each portion tell us something. That is, first one is about electrolysis, second one is conductance, and the third and the lastly is cells and batteries. Okay, and in our last 3 lectures we have completed our topic number 1, that is electrolysis. So basically in electrolysis we have covered what electrolysis is and what are the Faraday's laws. I have told you the Faraday's laws are very important theoretically as well as in the numerical basis. There would be a numerical come definitely on the basis of Faraday's laws that would be in your boards class, in your boards exam. So please concentrate on those topics. Now we're going to move with our second topic, that is conductance. Okay, so let's begin what actually conductance want to convey to us, what conductance want to define to us. All right, let's start. What is conductance? Before going to the topic conductance, you know very well that we have studied in chapter number 1, the solid state, that there are 3 kind of materials on the basis of conductance of electricity, on the basis of electricity passing through a substance, that is conductor, insulator, and semiconductor. So conductor are those which can conduct electricity, which can allow electricity or current to pass through it. All right, so let's begin with today's topic, the conductance of electrolytes. Basically electrolytes are of 2 types, or we can say conductance of electrolytes are 2 types. First one is electronic conductors, and the last one is electrolytes. We will just go through each topic one by one. Let's begin. What is electronic conductor is? Electronic conductor is something which can conduct electricity without being decomposition. That means these are those materials which can easily conduct electricity, but they do not need to decompose themselves. They do not need of any kind of, we can say, dissociation, so that they would allow electricity. So how the electricity is possible to conduct through them? That is possible through movement of electrons. And we have studied this. That is, for example, metals. For example, graphite. These all were the examples we have studied in chapter number 1. That is, through movement of electrons, electricity conductance is possible. All right. Now let's move to our second topic, that is the main topic of today's class, electrolytes. How electrolytes conduct electricity through them, how electrolytes allow the electricity to pass through them. All right, let's begin. Electrolytes are basically the substance or the compounds which can allow electricity, only after dissociation or decomposition, I can say. That means electrolytic conductors, or simply we can say electrolytes, both are the same things, don't confuse with them. Electrolytic conductors are those conductors which allow electricity to pass through them only if they have been dissociated, only if they have been decomposed. All right, so this is known to be electrolytes. Now the bases of electrolytes are of 2 different types, strong electrolytes and the weak also. I hope you have heard about the strong electrolytes and weak electrolytes in class 11. If don't, I'm just going to represent what is strong electrolyte and what is weak electrolyte. So let's begin. The strong electrolytes are those electrolytes which dissociate almost completely, which dissociate almost completely. Now, बच्चे, as I have told, कि conductance in electrolytes is only possible when they have been decomposed. That means their ions, they are moving and they are allowing electricity to move. That means if I'm talking about this ion, this picks up the current and it passes to another ion. Then this ion passes the current to another ion and so on. All right. So this is somewhat which electrolytes can pass the electricity through ions. Now, and if I'm talking about strong electrolytes, that means they can dissociate almost completely. That means they are producing maximum ions. And if they are producing maximum ions, that means they are producing, or I can say they are conducting electricity to maximum I can say content, the best word would be extent. Okay, so if we are producing maximum ions, that means the maximum conductance is possible. The maximum extent of electricity is possible through them. Okay, for example, the strong acid, the strong base like HCl, like NaOH. I hope you have remembered in 10th class. 10th class, we have studied that if I'm talking about strong acid or strong base like HCl and NaOH, whenever we dissolve them into water, they're completely dissociated into H positive and Cl negative. Same as it is the NaOH that can be dissociated into Na positive and OH negative. So these ions, that means cations and anions, the positive charge, the negative charge, they are allowing the light or current to pass through them. These are known to be strong electrolytes. Same as well, if I'm talking about the weak one, they do not dissociate completely. And since it is just opposite to that, that means there would be minimum number of ions. And if there would be minimum number of ions, the conductance would be a small extent. The conductance would be to a low extent. All right. For example, the weak acid, the weak base like acetic acid, or I can say like, for example, tartaric acid, salicylic acid, and so on. Okay, these are the examples of weak electrolytes. Now we have completely studied about the strong as well as the weak electrolyte. Now the next point is, what are the factors on which our electrolysis is dependent? I'm again repeating the topic. What are the factors on which our electrolysis is dependent? Okay. So let's start. According to you, would you anyone describe what would be the factors on which our electrolysis conductance would be possible? Anyone, if they have any kind of idea or any kind of suggestion, then please speak up. That what would be the maximum factors that would affect our electrolytic conductance? The first point is quite obviously the nature. That means whether it is strong or weak. Second point is solution, or we can say not solution, the which our electrolyte is dissolved. See, bache, we know very well that we have studied since in our 11th class, light dissolved light. That means polar wants to be dissolved into polar. And we know very well कि हमारे जो electrolytes हैं, they are totally polar, है ना? That's why they're breaking down into ions ना. If they're polar, if they're breaking down into ions, so they want to be dissolved into the solvent that are also polar. Okay, so solvent, if the polar they are, more dissociation, and I would say the more conductance. right? Same as it is, I would say the size of ions, and finally temperature. Size, how it is dependent upon the topic. See, if I'm talking about the size, if the size of ions is greater, the conductance would be low. That would be very slow moving, and the moment would be slow, their conductance would be low. Okay. And finally, if I'm talking about the temperature, the more the temperature is, more would be the dissociation. Why is it so? Because you have studied that if there would be more temperature, there would be more kinetic energy, there would be more dissociation, and finally there would be more conductance. Okay, so this was the topic that was totally dependent upon conductance of electrolytes. Now we are going to elaborate this topic in the terms of resistivity, conductivity, conductance, or specific conductance, and many more. Okay, I hope you have studied them in 10th class physics also, but now we're going to take them in a little bit detailed topic. Okay, so we are going to take the same topic, that is what are the terms conductance, specific conductance, how they're defined, what are their benefits to us, how they're used in mathematical quantity, but we would see them in a little bit elaborated manner. Okay, so let's see. That is our next topic. First start with the electrical resistance. Okay, but the topic now we are going to study, this is very important due to basis of the numericals as well as some theoretical terms also. We will see how these theoretical terms are important. So let's begin with our first topic, resistance, or I would say electrical resistance. Okay, now you know very well that whenever the conductors are passing the electricity through them, there is always a kind of resistance. That means there is something which resists or which stops the electricity to pass through them. That is known to be resistance. Okay. Now the resistance term was cleared by the Ohm, that was a scientist, and we have named it Ohm's law. What Ohm's told us? He told us that if we have a conductor and the end of conductor is applied through voltage V, and we have applied the current I through it, then V equals to IR, where R is known to be resistance, or in short, I would say it, V is directly proportional to I. If we would remove the proportionality constant, then there would be R. This is known to be resistance. So in short, R equals to V upon I. This is known to be resistance. That means Ohm's law is defined as resistance R is equal to the voltage V applied to the conductor divided by, or the ratio of it to the current which is we are passing through that conductor. Okay, that is known to be resistance. Now you have must heard the unit of resistance is Ohm, or we can put it in this symbol. This we have already studied. Now this is something which we have studied, the resistance, but our topic is conductance. So we are further going to move to our next topic, what is known to be conductance. Okay, so let's move to our next topic, what is conductance. Okay, as I have told you already that resistance is something which resists the electricity to pass through. So the conductance would be just inversely proportional to it. And we have defined the conductance as G equals to 1 upon R. That is, the reciprocal of resistance is known to be conductance. Its unit would be, since it is the unit of inversely proportional to resistance, its unit would be Ohm inverse. Or we can also say it Moho, or we can also say it Simon. That is S. Okay. Now, this was very basic topics you have already known. we are going to move with our next topic, that is specific conductivity, or we can say equivalent conductivity or molar conductivity. We would say why we need to study these topics. मतलब हमें पता है कि हमारा एक टॉपिक रेजिस्टेंस होता है, कंडक्टेंस होता है, and we can easily jump to our conductivity or resistivity. But the point is, why do we need to move to our topic equivalent conductivity or molar conductivity? है ना जी? So let's move to our next topic. What is conductivity and why there are different types of conductivity like equivalent as well as molar, and what are the importance to us? Okay. So let's move to our next topic, that is conductivity, or we can say specific conductivity. Let's move. The specific conductivity. We are doing the second topic, conductance, the second portion of electrochemistry. And the topic is specific conductivity. Or nowadays, according to the IUPAC, we have given it the name conductivity. So conductivity then specific conductivity, but don't confuse, don't mess up with specific conductivity and the conductivity. Okay, so let's begin. As I have told you that there is known to be a quantity, that is resistance, which is due to movement of electrons, so movement of ions, I can say, or due to current and voltage we pass. So the resistance is known to be directly proportional to length of the conductor divided by area of the cross section of the electrodes. So we have assumed, we have known that if we are putting a conductor with length L and we have put two different electrodes into it, the area of electrodes cross section, the area between them, resistance is known to be directly proportional to the length and inversely proportional to the area of cross section of electrodes. Okay, so we have come to know that there are two different factors on which our resistance are defined. If we are removing the proportionality constant, then we get rho. Okay, RH or rho. R equals to rho L by A. This rho is known to be specific resistivity, or simply we can say resistivity. But class, as I have already told you, we have to prefer the conductivity or the conductance topic, because that's the topic in our main syllabus now. So I would define that, I would say, okay, first of all, I need to define what is rho. Rho could be equal to the resistance if the length is equal to 1 centimeter and area equals to 1 centimeter square. Okay, in that case, R would be equal to rho. So this is something known to be specific resistivity. Now I would define the specific conductivity. As we have seen in conductance, that is inversely proportional to resistance. So specific conductivity is defined to be G, and it is equals to 1 by rho. Okay, so specific conductivity is defined as it is equals to conductance whenever we have the conductor of length with 1 centimeter and the area of cross section between two electrodes equal to 1 centimeter square. That is known to be our conductance. That is known to be our conductivity, or we can say specific conductivity. बन रही है जी बात? So this is known to be G, that is known to be specific conductivity. Okay, now let's just quickly go through their units and then we would jump to our electrolytic and the molar conductivity. Now, if I'm talking about the units, what could be the units? If I'm talking about rho, it would be RA upon L. Okay, and we know it is equal to ohm. This is equal to centimeter square upon centimeter. That is ohm centimeter. This is the unit of resistivity. And if I'm talking about conductivity, it would be ohm inverse centimeter inverse, because it is just inversely proportional. All right, let's go through. Now we are going to move with our next topic, the types of conductivity, the different types of conductivity, in which we will discuss the molar conductivity as well as the equivalent conductivity. Okay, so let's begin. All right, class, the next topic is equivalent conductivity. Now the point is, why do we need to study them? Okay, I hope you have remembered that whenever we have done in the chapter number 1, the solid state, I have told you 3 different things. That due to conductivity, we can differentiate metals, conductors, semiconductors, and insulators. Okay, so same as it is, if we can differentiate our metals, or we can say elements, we can also differentiate our 2 different type of solutions in which our conductivity is going through, or 2 different type of electrolytes through which our conductivity is going through. Suppose I'm talking about HCl and NaOH. Okay, so to compare them, to check out the differentiate the conductivity between the 2, we have 2 different options. First one, let me take their volume would be same, and second one, suppose the number of ions, that could be the gram equivalent, or we can say the molar, number of moles. Okay, so on the basis of these 2 terms, since the volume is same, so we are not focusing on that, we are not concentrating on that. We have the second option, the number of ions. We can say how much number of ions are actually present in 1 ml of a solution. If I'm talking about HCl, I would say in 1 ml of HCl, how many number of ions are over there, so that they can produce conductivity. So we need to focus on our 2 different topics, that is equivalent conductivity as well as molar conductivity. Okay, so let's move to our first topic, what is equivalent conductivity. So equivalent conductivity is defined as the conductance of all the ions produced from 1 gram equivalent. Conductance of all the ions produced from 1 gram equivalent. Okay, and since I have told that this is something which is conductance of all the ions which are producing from 1 gram equivalent, but the definition is not complete ना, क्योंकि हमने अभी पढ़ा था कि हमारे पास एक कंडक्टर होना चाहिए, हमारे पास कुछ लेंथ होनी चाहिए, हमारे पास कुछ एरिया होना चाहिए. So I would elaborate the definition as the conductance of all the ions produced from 1 gram equivalent with length 1 centimeter and the area of the electrodes such that all the ions are present between them. Ions are present in them. Okay, so it is known to be the equivalent conductivity. Since we have used the term gram equivalent, so you must have remembered in chapter number 2 we have studied the normality, और हमारी जो normality थी that was totally dependent upon gram equivalent. Okay, so let's further use this term to give some numerical formulas. Okay, so let's see. All right, this is known to be equivalent conductivity, which is represented by lambda. This is represented by lambda equivalent. Okay, now the lambda equivalent, that is equivalent conductivity, how is it connected with our specific conductivity, or we can say normally conductivity? That is known to be kappa into V. Okay. Now, what is kappa and what is V, and how can we define them? I have already told you कि हमारे पास जो terms थी resistivity that was due to the area and the length, and हमारी जो conductivity थी that was kappa, that was lambda equivalent equals to kappa into V. That means this is specific conductivity into volume V. Since we are taking the volume, so lambda equivalent is equals to kappa into 1000 divided by normality. Or we can say kappa into 1000 divided by gram equivalent. But let me clearly define you that this is V is something which is in 1000 ml. We can say the number of gram equivalent ions in 1000 ml, that is equals to V. तो ये हमारा जो टॉपिक है that is somewhat resembles to chapter number 2 solution, क्योंकि उसमें भी हमने यही स्टडी किया था that we have normality into 1000 ml, or we can say the number of gram equivalent ions in 1000 ml, that is equal to the lambda equivalent. Okay, now that is molar conductivity. How would the molar conductivity would be defined? The molar conductivity would be defined conductance of all the ions produced from 1 molar solution. 1 molar solution, where the length is equals to 1 centimeter and the area is something in which both our electrons are present. Okay, so molar conductivity, equivalent conductivity, specific conductivity, or we can say simply conductivity. These all are the 3 different terms which are very important, very crucial for us. Okay, so how would I would define it? How would I make it into the solution? I would say it is equals to lambda m, that is equals to kappa into V, and this is equals to 1000 divided by molarity. Okay, so बच्चे ये बात हमेशा याद रखिएगा कि whenever we are talking about the equivalent conductivity, we are taking gram equivalent ions. That means हम वहाँ पे normality की बात कर रहे हैं. And if I'm talking about molar conductivity, we are taking 1 molar ions. That means हम वहाँ पे molarity की बात कर रहे हैं. The 1000 is something which is to be in ml, that is in 1 liter. Okay, this is going to be our molar conductivity. Okay, since we are left with only 5 to 10 minutes, I'm just going to finish the topic with the last topic, that is going to be the cell constant. Okay. Okay. Now, Bache, I'm just going to pick this topic. The last topic we are left with cell constant. The cell constant is nothing. It is a term which is equals to kappa is equal to G into G star. The cell constant is defined by G star, and the G star is equals to L upon A. If I'm not wrong, let me check. Yes, the conductivity, which is equal to conductance into L by A, this L by A or G star is going to be cell constant. Now the point is, why do we need to take cell constant? See, we have so many different electrolytes which keep dissociating. So we need to take any kind of fixed electrolyte or any kind of fixed solution which has some same type of conductivity, or we have all the different type of conductivity at different temperature. क्योंकि हमें पता है as the temperature would increase, हमारी conductivity फिर से change होती चली जाएगी. So there is a compound known to be potassium chloride, KCl. KCl is something of which we have known to be all different conductivity at different temperature. Okay, so we need to just have a area that is known to be cell constant G star. ये तब possible है जब हम अपना KCl solution के अंदर कोई cell हमने put किया है and we have taken it as cell constant. Okay, So this was nothing. This was just a topic which is related to the topic cell constant as well as conductivity. Okay. So now class, we are left with the topic we're left with the applications of all these three topics. That means the numerical portion. So in next class, we will check out the numerical portion based on this topic, and we will see how is the conductivity possible whenever we are making the solution dilute or concentrate. यानी अगर हम अपने सॉल्यूशन के अंदर ज्यादा सोलवेंट ऐड कर रहे हैं तो क्या हमारी कंडक्टिविटी पर इफेक्ट पड़ेगा, क्या हमारे नंबर ऑफ आयन पे इफेक्ट पड़ेगा, एंड दैट विल लीड टू आवर कंडक्टिविटी. ओके, so in tomorrow's class we will just go through with some numericals based on cell constant, on specific conductivity, on equivalent conductivity, and finally we will see the conductance, or we can say the conductance depending on the dilution. All right, so this was all about by my side class in today's topic. If you have any kind of doubt or queries, please ask to me. I'm open to your doubt and queries.